Hi, this is Samuson, Assistant Professor at National College of Technology. As I said, we have discussed a lot of things in the previous classes, right? What are the different type of sensors we are using and how plays a major role, and what is the how the touch sensor has been taking place in the industrial sectors. Previous classes. Today we are going to discuss about the continuity of the previous video, right? So this video we are going to discuss about the capacitive touch sensors. We can directly into a presentation where we are able to describe what are the different applications and how it has played a major vital role. Okay, right. So as I said that capacitive touch sensors are one of the important one. The capacitance of the values which are given to the term. So capacitive touch sensors are normally widely used in like mobile phones, MP3 players, and smartphones. The capacitive phones everywhere in like home applications. And where I said automobile industry applications. The reasons for this development of durability and robustness, the attractive product design, developments of this type of touch sensors. Touch sensors, as I said, normally unlike the mechanical devices, does not contain moving parts. They are more durable than mechanical input devices. Touch sensors are robust as there are no openings for humidity and dust to enter. So, as I said, these are about the basic of touch sensors, right? Now, the principle of capacitive touch sensors, we are going to discuss about the measurement of the electrical disturbance from change in the capacitance. This is the simplest form of capacitor, can be made with two conductors separated by an insulator. Metal plates can be considered as conductors, and the capacitance can be identified by the formula of C is equal to eta naught into eta R into A by D, where eta naught is an permeability for free space, eta R is an relative permeability or the dielectric constant, A is an area of the plates, and D is the distance between them. As I said, the relative. The capacitance is directly proportional to the area and inversely proportional to the distance. So in capacitive touch sensors, the electrode represents the one plate of the capacitor. The second plate is represents the two objects. The one is the environment of the sensor. Form parasitic capacitance C naught, and other is non-conductive objects like a human finger, which forms touch capacitor CT. The sensor electrode is connected to a measurement circuit, and the capacitance is measured periodically. The output, what I said, conductive objects touches or approach the sensor electrode. So trigger signal. So normally the working principle as shown in the figure, if the area of the sensor electrode is bigger and thickness of the covering material is less, the touch capacitance is also bigger. As a result, the capacitive difference between the touching pad and the untouched sensor pad is also big. This means that the size of the sensor electrode and covering the material will influence the sensitivity of the sensors. The measuring of capacitance is used in many applications by determining the distance, pressure, acceleration, etc. Frequency modulation, time delay measurement, duty cycle, etc. And this form of capacitance sensor presence of conductive material is high enough to trigger the load, and as well as change in the, and there is a multiple touch can be detected in the capacitive touch sensors. So these are the type of sensors where external conductors like human fingers comes into contact with the surface. The capacitance is formed between them and draws more current from the corners. The current at the each corner is measured, and the ratio will be determined the position of the touch on the surface. In the projected capacity sensing, the whole surface is not charged, but an grid of conductor is placed between the two insulating materials. The grid is often made up of copper or gold PCB or iron. The IC is used to charge and monitor the grid. So this is how the capacitive sensors acts as the proximity sensors by using the index fingers. So the main applications of capacitive touch sensors are iPhones, iPads, and home application of touch lamps, and automobile applications and industrial applications. They are widely used. So there is no required pressure, and it is built on a glass itself. There is no extra element is required. So there is a support of multi-race. Even though multi-race, there is a high response. Similarly, disadvantages, and everybody knows that vulnerable to abrasion, and they are reliability concerns when they used in harsh environment, and we cannot work without the gloves materials. So this is about the capacitive touch sensors. In the next video, we can discuss about resistive temperature. Till then, bye bye. Signing off by Sambasam, Assistant Professor, SNS College of Technology.